Hello, geometry students. Today we are starting lesson 5.5 and we're going to be talking about proving triangles congruence. And notice we have a new acronym over here. We have SSS. What do you think that SSS stands for? So the first thing I would like for you guys to do or to think about is if we have three specific side lengths, so three specific side lengths, okay? Has to be three specific lengths. So if we think of maybe a paper clip, something like that, and a pen. So a pen is going to be this long, and then let's think of a ruler. So if a ruler is this long, do you think we can put a paper clip, a pen, and a ruler together to make a triangle? Can we connect them by end to end to end, and connect them to make a triangle? So will three segments always make a triangle? And the answer to that question is no. Okay, it's not long enough. Like the paperclip and pen together are not long enough to make any kind of angle. So it would go like this, would be our paperclip, and then our pen would only reach to here. It would never get quite to this end point. So what happens is, to make a triangle, the two shorter sides, or two sides, always have to be greater than the third side. So whenever you're making a triangle, the sum of two sides must be always greater than the third. So with that in mind, let's think of some other lengths we could have. So let's just say we have a 3-inch, a 4-inch piece, and a 5-inch piece. Okay, so if we were in the classroom, I would have you cut out something that's 3 inches long, 4 inches long, and 5 inches long, and I would have you put them together. And I'd have everyone in the classroom put them together. So we are stipulating three sides. That's where we're getting SSS for side from for this lesson for today. And I would have you measure that out. So this would be your 5 inches. And then we would have a 4-inch maybe over here, and then we'd have the 3-inch here. Now I know mine's not drawn exactly to scale here, but what we would find out is that every single one of you, so if someone else put their 5-inch up here, and then they put their 4-inch here, and then their 3-inch here, that that was supposed to be a 4, then everyone put them together and we cut them out and we put them together, you would find that every single one of you made the exact same triangle. No matter how you put these pieces together, you can never get anything else so that this angle would always match up to that one. They would both be congruent. This angle between the 3 and the 4 is always going to be 90 degrees. There's no other way you can put these three segments together so that you do not get between the 4 and 3 that this included angle is 90 degrees. And this angle right here would be congruent to that angle right there. Every single time, all of you, if you made that, that's what you guys would all find. So what we find out, you see how they made QT, sides are congruent, PQ is congruent to SR, and these. There's no way that anybody can take three specific sides and put them together and you don't all make the same triangle. So this is what we call the side congruence. So three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So we've been working with side as one of our shortcuts. Well, now we just added side to that list that we have. All right, in a right triangle, so just learning some things about a right triangle. A right triangle always has a hypotenuse, and the hypotenuse is always the longest side, and it is always across from the right angle. The two sides that come together to form the right angle are both called legs. Now, they do not have to be congruent. They're both called legs. Sometimes I call one the short leg and one the long leg. So I call them something different like that, but they are both considered to be legs. So valid triangle congruent shortcut. So we've got side angle side. We've been writing and using those for proofs, and we just found side 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 is valid. So do you think if you took two sides and the angle not between it, see how this A is on the end, it is not between the two? If the A is on the end, do you think this is a valid shortcut? So if you made one side and another side, and then we made this angle a certain angle, would it always come out to be the same, that this triangle is going to be congruent to your friend's triangle or to everybody else's in the classroom? And as it turns out, 90% of you make the same triangle. Sometimes it has to be just me making the other one, but 90 to 100% of you always make the same triangle, because we don't always think of some obtuse triangles. So the answer is no, this does not work. And here is the example. So this is typically the example, FED, that you guys would make. You would make FE congruent to BC. Those two blue sides would be congruent. And you'd make this one congruent. And we would make this angle in here acute. That's what most all of you would have made. But if we make this obtuse so that it's coming in at a different angle, so take this exact same side and just have it come in here, so that this side is congruent to that side, we could have put F in here instead of out on the others. And so that's what they're trying to illustrate. And so that's why side-side angle does not work. Now, how do most kids remember that side-side angle is the one that doesn't work? Well, maybe some of you have noticed, maybe some of you have not noticed. But if we write that the other way, it does not spell a word that you are probably able to use in school appropriately. So we always remember that the side-side angle, if you say it backwards, I will never write it the other way, but side-side angle is the one that does not work, because the difference between making this acute or making this obtuse makes the difference between that those two triangles being congruent or not. Now, there is one exception. I talked about there being an acute angle and there being an obtuse angle, but if we talk about this angle being right, so there is a fine line between being obtuse and being acute when you get those two together. So as we are moving this point F out, 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 and this point, if it comes out halfway between those 2 points, between acute and between obtuse, it ends up being a right triangle. And if it is a right angle in there, that does work. But instead of us using side-side angle, what we do is we call that hypotenuse leg. Because the only way you can have an obtuse angle, the only way you can have a hypotenuse in the triangle, to have hypotenuse, is if it's right. So we call it hypotenuse leg instead of side-side angle. So if you have a right triangle and the two hypotenuse and one leg is congruent, then the two triangles will be congruent. So we don't even use 3 letters here. Because it's being hypotenuse, we are telling you it's a right triangle. So there's your angle, here's your side, and we go side, side, angle, but we call it hypotenuse leg so that we know that we have that right triangle in there. All right, so given here all kinds of information, let's see here if I can get all of this on the screen. So given that WY, so the big long diagonal here is congruent to the other diagonal here, and WZ is perpendicular. So we have perpendicular here. So remember, perpendicular lines mean we have a right angle. So when you have perpendicular, we have a right angle, which now means that we have a right triangle. So this comes down, and because it's perpendicular, we have a right angle. So now we have a right triangle. So we just made those two hypotenuses congruent. Well, now is ZY a leg in both triangle? So we went from perpendicular means we have a right angle, and if we have a right angle, then that means we have a right triangle. And if we have a right triangle, we only need to get two sides congruent, the hypotenuse, which they gave us, and zy from reflexive. So now we can get the two triangles congruent by hypotenuse leg. So notice here in this proof that we had to say that it is right. Okay, and once we can say that it is right, now we can say that they are right triangles. And then we use the reflexive property, and they already gave us from here the hypotenuse, and now it's a right triangle, and we use the legs, so we can use hypotenuse leg. All right, that is the end of the lesson. So just remember, when you're writing a proof and you're going to use hypotenuse legs, you're going to go from perpendicular lines, which means you have right angles, which now means you have a right triangle, which now you only need two things to get congruent, the hypotenuse and one leg. So if you're going to write a proof, it's going to go perpendicular lines, means you have right angles. If you have a right angle, then you have to have a right triangle. And now if you have a right triangle, you only have to get two things congruent, the hypotenuse and one leg. So the two things today are that right triangle, hypotenuse leg, and side, side, side. All right, good luck on your homework.